In this presentation, we will speak about the graphic method calculation that is also called the Maxwell diagram. The big advantage of this particular method is that we can use the skill of what architects do the best, that is to draw. Well, instead to do calculations, you will need to use all these tools in order to make the diagram. Please make sure that you make the diagram in a big piece of paper and that you use the tools that are necessary to do it. You can also have a transporter to measure the angles and make sure that the drawing is well made, because usually you need to upload the drawing after the test in Canvas, and you will be evaluated according to the precision of the calculations. And the drawing will give us the measure of the forces that each one of the elements is supporting. Therefore, it's important that you make the drawing as big as possible and very well made with a correct scale using the adequate angles. Do not be lazy and do something approximately by hand, because your project will not work at all. Well, we will look a little bit about what is the bow notation, make the Maxwell diagram, and interpret the Maxwell diagram. We have here a truss that is made out of several members. As we can look, this truss is a truss that have an element that is not triangular in this section. Well, this type of truss normally cannot be calculated by this method because they will have mistakes. And it will not be possible to do it. Well, we need to make sure before you do the calculations that the truss is determinate. If the truss is not determinate, you can write in the test, if the truss is not determinate, we didn't learn how to do it, and that's it. You don't need to do the calculations. Well, bow notation is a system that will help us to understand the name and give a name to each one of the members of the truss. The space between the lines of actions or forces acting in the joints will be written a specific name. Usually can be a lowercase letter. Any force is corresponding designed by the letters of the two spaces separated by the line of actions. In few words, we have this particular truss that is determinate, okay? Well, sorry, this truss have here a member that is different to the other one, but it's okay. For the moment, let's just imagine that we are just doing the bow notation. Well, what we'll do is that we'll go to the corner, left corner of this truss in this point, and immediately up of the reaction or the corner, we'll write the letter A. Well, look, the letter A is the space between reaction 1, because this is reaction 2 normally, and this particular force is the space. Well, this space is shared by two forces, one in red, another one in brown. Well, we do the same with the next space. The next space is going back here, and we have B, that is the share between the red one and let's call the blue one. And we put C in the next, we put D in the next. We have reaction 2 here. Well, that means that we need to put a new name in this side, and we have only E for all this area. Why? Because we don't have any force in this point. We don't need to put two names. Got it? I mean, if I had, for example, three reactions, then this area will be D, this will be E, this will be F. But that is not the case. Well, I don't have anything, this area, all this area will call E. Well, what is interesting now is that each one of the reactions and each one of the forces that is acting in pink color has a name we can identify. For example, reaction 1 is the vector EA. This force is BA, and this one is BC, and this one is CD, etc., etc. After we finish in the exterior part, we go to the triangles in the inside, and we put the rest of the names, okay? We don't have this name here because obviously we know that in this case, we are not supposed to have this member there. That member is not supposed to be there. And well, now each one of the elements have a name. Let me clear everything. And well, we see member EF, member EH, member FE. Well, in this case, the truss doesn't have the additional member that I had before. Well, we can start the calculation of these trusses. Well, the Maxwell diagram is the second step while calculating forces in truss members. And what we normally do is to make a diagram as follows. Please be careful. This particular diagram that I am showing you do not have numbers. But you will always have numbers in the test. And if you don't have, you will write them. For example, it's the same what you write, because if I write 5, 5, and 5, it's obvious that this is 15. That means this reaction is 7.5. And this reaction is 7.5. Instead, it's 10, 10, and 10. Well, here we'll have 15 and 15. Well, the number is not particularly important. What is important is the proportion. Here, the proportion is that this element is 1/3 of the total loads, and this is half of the total reactions. The proportion is what is important, because when we do a drawing, we do by proportion, and every one of you will have a different scale doing this drawing. You will not choose necessarily the same scale. Well, imagine that you have the numbers. Well, it's obvious that you will need one pink element and half to make a reaction. Always, no matter how much is the pink load, always the reaction will be equal to 3 times the loads, because we have 3 loads divided by 2, that is 1.5 the dimension, and that is the proportion that you will be using in your case. Let me I just did a mistake here, I apologize. Take out this and clear everything. Well, having the proportions, I will give you some numbers here. For example, I will tell that this one is 2 pounds, or any other measure of weight. Therefore, 6 is the total. This will be 3 and 3. Well, I will now draw the different elements that are acting in this truss, the different forces. And that is something simple, because it's like an equilibrium of forces. And you already studied that in physics, I guess. Imagine that you have an object, and in this object, you have 4 forces that are acting. For example, force 1, force 2, force 3, and force 4. Well, the equilibrium of this element will be force 1, let me put the same color, force 1 minus force 2. That will be 0, because they are equal, different signs. And for force 3, plus or minus force 4. Well, that will be 1 force like that, contrary to a force like this. You start in the same place, you finish in the same place, the resultant is 0. Imagine that we have a beam, and we have those forces, 2 reactions, and one load. If the load is 10, the reactions is 5. Well, what we do to find the equilibrium of forces? We just tell a vector of 10 going down and two vectors of 5 going up. I arrive to the origin, same points, the summatory of forces is equal to 0. Well, we will do the same here. We'll take all the forces that we have and we'll start drawing them. For example, I have a vector here. Normally we start always with the first load. Well, this element, I will take it and transport to the place where we have the rest of the elements. Okay, I will take this element and put it here. Let me do it here. I say, by the way, A can be in any place. I can start my drawing here, here, but I will always start in the left side because the drawing of the truss will be in the right side. Well, I took a vector A, B. I make after a vector BC going down, another vector CD going down, and after I have two reactions, and the reactions are as follow. DA, okay? That is this one, DE, sorry. Starting D and we go to E. And the next one is AE or EA, starting in E, going to A. Equilibrium of forces. Everything in a line. Well, I am just copying the same proportions. If this guy is 5, I will take 5 equal 1 inch. I write a line of 1 inch. It's important to have a scale. And after I write a line also of 1 inch, that is the next one of 5, 10, or whatever is the proportion, another one of 1 inch, etc., etc. And I finish in 0. That is the first step, to just draw the loads and the reactions, okay? The next step, let me go here. Is to complete the rest of the polygon forces starting by the first corner. For example, I will start at the point where it's A. I will start with, always starting in this corner, I will start with AF and AD. This F, let me go back, sorry. This F is the one that is here in the middle. Well, what I will do is that I will take this line. Sorry, let me go back. I will take this line. I will put in yellow color this line. Sorry, let me go back again. I think that is better that I do it like this. I will take this element that is A, F, and I will move using my tools in the place where is A and extend in a line like this, in a long line like this. Well, I take the same inclination and just starting in A because A, I have A, I don't know what is F. F is in some place in this line. F can be in some place there. Well, I write that element. After I take the element EF and I move where is E. I will not move in the other side. I will move always in the left side and extend it. When I extend, I have already drawn the lines AF and FE. One starting A and finishing F, the other start in E and finishing F. Where is F? The place where they touch. That is the new point that is called F. Well, I can draw in my diagram the point F. Let me just copy and paste and have my F here. Okay? And you will be doing this by hand. The next one, I start with AF. After FE, I go to the next. And the next is FG. It passed through F. Well, I take the same line, I copy, I put there, and I extend the line. I extend that line. How much I extend? You just make a tiny line, like very long. And thereafter, you need to find the point where is G, because you have you have F, but you don't know where is G. G is in a place because a line has two names. It's in a place in that line. Well, in order to do that, you look what other element you have with the same name, and the one that I have is BG. Well, I take BG, I start in B, I extend the line with the same inclination, okay? And well, in the place where GB touch GF, the two lines touch, that is G. Well, we discover G in this particular point now. G is there. Sorry, G will be in this area, here. And we write the name G. And like this, we continue. Okay, G is the intersection between the two lines. Well, we go to the next. What can be the next? For example, we have a letter that is called HI, but we don't have yet the location of H. We suspect where can be, but we don't have it. But we have another vector that is called, this one that is called GH. Well, I take GH, I already have G, it's important to have one point, okay? And I put it here, and H is in some place of this line. I made this line long, because I don't know where will be H yet. I made the line long, and I find another element that could help, okay? And the next element that could help for this particular case can be HE. Look, HE is a vector that start in H, so the starting E is a line that start in E, and it's very long. I make it long and try, let me put it straight. And in the place that these two lines intersect, I have H. You see? Well, let's do it. In the next, we erase the elements that we had, we make the line, and we find H. We erase, look, that those are the original lines that were longer. We erase the part that we don't need because there is nothing there. You know, we go between G and H. We don't need to extend. Well, we erase and we have H there. And that's it, because the next part is symmetrical. It's exactly the same. We already have the Maxwell diagram. What is interesting of this particular element? The interesting part is that in the same way that if we have a number here, I decided, for example, in the past that this was 2, 2, and 2. If I use the adequate scale, for example, I say 2 pounds equal 1 inch. Well, this is 1 Abine, this is 1 inch, is equal to 2 pounds. Well, I can take now any member of this truss. For example, I take this member that is here, that is called FA, and I measure. I measure and I tell, well, this element have now, for example, if I draw correctly, I will say I have 1, 2, 3. Imagine that is 4 inches. Well, if 1 inch is 2 pounds, 4 inches is 8 pounds. Well, this particular element is supporting 8 pounds. Okay? It's like I measure and it will be exactly the weight that this element is supporting. And that's something good because very easily we can have an approximation because it needs to be perfectly made by a computer to be exact. But we will have an approximation that the force FA is probably the one that is, this particular member is probably the one that is supporting more weight. I can tell you in the test, guys, how much weight is supporting the member GH. This is the member GH. Well, what you do, you look GH in the particular diagram, and you just measure this one. You measure according with the scale and look, if the other was 1 inch, this is a little bit more. You measure, imagine that is 1.3. Well, you just do the calculation and multiply 1.3 multiplied by 2 is 2.6. Well, probably this element is supporting 2.6 pounds, etc., etc., etc. And that is the way that we can do calculations with this particular method. And it's a little bit the interpretation of the magnitude force of each one of the members. And we have some explanations here that you can read and you can practice. In the book, there are several programs to do it, and you can try to do all of them. We have another method here that in this case is relatively easy because we have the proportions. Not always you will have the proportions. Look, in the other case, I just move with this element like that, but you will need to use your triangles to do it. When you have the proportions, it can be easier because you have the triangle that you will have. And well, look, we have 4 bays of 3 meters. A bay is this particular area here. This one is 3 in one side and 3 in the other side, 3 units. Well, that means that it's a perfect square. That means that all the lines that you will have will be vertical, horizontals, or diagonals in 45 degrees. It will be very easy to draw something like this. Well, in this case, we have the reactions that are 4 and 4 because the loads are 8, 6, 6, 6, and 1. Well, you can do the same drawing that we did before. We did before. And you have the explanation here how to draw the truss. Okay? You need to measure out the lines to make sure that the proportions are adequate. And well, we have a scale here for forces. This is the scale. Well, we have 1, 2, 3, 4 units. It's kilonewtons in this case. And we start drawing one line of 1, 2, 2, 2, and 1. And we start doing, let's do it here. I have the same, but let me try to do it with this one that is the same. Well, let's try to do it here. Okay, first I do the board notation, and this case we have A in this corner. You don't put A there. You put A after this number, A, B, C, D, E, F, G, and you put all the numbers inside, okay? Well, let's make this in the following way. We'll try to take a pencil of a different color. I will start with blue. And those forces will be blue. And well, we have AB. Look, it's 1 unit from 0 to 1 because it's 1 unit. I draw a vector 1 unit down. After we have BC, that is this vector, is 2 kilonewtons. I go 2 units. 2 units mean this length. It's important that you draw the scale, please. Don't forget, if not, your drawing will not work and you will receive a 0 if the scale is not adequate. I have this one here. I can put an arrow to show it what I am doing, but it's not necessary. I go with the next one, 2 units. I discover what is D. I go with the next one. Okay? 2 units. I discover what is E. And finally, I do the last one, EF. That is this one of 1 kilonewton. I go down 1 kilonewton. After I go with the reactions will be in red color. We have R2 and R1. One is called FG. Well, FG is 4 units. I mean, all this vector will be here, 4 units, plus the next one that is 4 units, and I stop and finish in 0. I start in the point A and finish in A. Well, in this case, it's working well. I already reviewed that the number of members was adequate, a number of joints. Okay, I count the number of members. In the case, it's not necessary because I already know that it's a truss that have a triangle, and for every 2 members, I have 1 joint. For every 2 members, I have 1 joint. Well, it will be determinate. I start with the first one, and normally we start always in this corner and with the reaction AH or HG, depending what we have. Well, look, the first, we have a vertical member. I will put this vertical member in green color, a vertical member here, sorry, green. And this element starting A and finishing H. I have A here. I don't know what is H. Well, I can make a long line, okay? I make a long line starting in A. I imagine that will be in the inferior part, obviously, well, I will not do the line there up, I will do the line here. I start in A and finish somewhere. AH is in some place here. I mean, we already have the start that is A here. We need to find where is H in this line. Let's go with the next force. The next force is HG. Starting H is this one. Let me put in color pink. HG. HG is a vertical element that's starting H. Well, I will never draw in this side. Well, I will draw in this side and I make a long line. And this line is the line H that is there and G that is in some place. Well, where is G? In the place where the 2 lines cut, and the place is this one, in that center. In that point, we have G. Well, I can erase and just write here G. By coincidence, G and H are in the same place. Another thing that is interesting is that O will be also in the same place. Well, it's a line that is like pointing to you. It's a line that is a point. It's not a line, because both go in that particular area. And like this, I continue. For example, I have HI. HI is this particular line. Let me take it. Sorry, this one I cannot copy. I copy this line, move it, and this line starting H, well, I know that H is over there, and I extend it. And in some place of that line, we will have I. Well, I can tell myself, let's do IJ. But I did a mistake. I need to do BI before, because IH, I don't have IJ, I don't have Jake. Well, I need to go by order, and the order is BI. Well, BI starting B and finishing I. I don't know what is I, but I know what is B. Well, I start in B here, and I do a straight line, and in the place where G in the place where BJ this one touch the other element that is HI, that is this one. Let's change the color, this red. In that place is I. And I can go with the next one. For example, Jake I. I already have I. That is there. Let's close. Let's clear everything. I already have I. Well, I can try to look what is IJ. I make a vertical line because this line is vertical. I keep the same proportion, and J will be in some place. I don't know where, but J will be in some place of that line. Well, let's look another line that have a J, and that is G, Jake. We have G already. We made this line, and in the place where they close, then we have the common letter between them. Well, after you arrive to half of the truss, the rest of the truss will be exactly the same and symmetrical in this particular case. You have a media presentation from YouTube where we have trusses that are not symmetrical like this one. And this concludes this presentation.